this video we're going to learn about standard form. Sometimes it's called scientific notation, sometimes it's called standard index form, but it all means the same thing. So what this is it's converting very large numbers into a simplified expression, or vice versa, very small numbers into a much easier expression. And our calculators are programmed to use standard form. So why would we need very large numbers? Well, let's do an example. The Earth to the Sun, I'm just going to write this down. So the distance from the Earth to the Sun is approximately 150 million kilometers. That's a very large number. The mass of an oxygen atom is approximately, now there are so many zeros, it goes 0.000, it keeps going. And in fact, there's so many zeros, and then right on the end, I think there's even a few more zeros, and then there's a point and a 26, a 026. It's a very small number. So these are examples of why this is useful for us to be able to write in a more appropriate way. Writing all these zeros is mundane, so that's why we use standard form. So what I'm going to do is I'm just going to write this down. This isn't the exact mass of an atom, oxygen atom, but it will at least give me something to be able to write down. So let's look at this. Now, this is done by significant figures, basically. A significant figure is a digit. 0 does not count as a significant figure if it's before a number, but it does if it's in between two other digits. So if I had, say it was that 206, this 0 counts as a significant figure. So this is actually 3 significant figures here, including all this number. This one here, well, this one is 2 significant figures here, and these ones don't count. Alright, so what I'm going to do is I'm going to have this number here and write it in standard form. So the 2 significant figures are 1 and 5. So what I need to do is have a number between greater than 1 but less than 10. And because if I go above 10, I've got another power of 10, because standard form is all about powers, writing a number in powers of 10, because we know that's what the zeros are, they're powers of 10. So 1 and 5 are my significant figures, so I'm going to make that 1.5. Now, the decimal point would normally be here for 1.5, and all I've got to do is count how many places the decimal has to move till I get to the end of the number. So I've got 1, 2, 3, 4, 5, 6, 7, 8. That means that 1.5 can be times by 10 to the power 8 to give me this large number here. So that is now written in standard form. Now, let's look at this very small number. We've already talked about this as I changed it. We've got 206 are our significant figures, and I need to find a number that's greater than 1 but less than 10. So I'm going to choose 2.06. I can't change the order of the digits. They have to be like that, but it's got to be where I put the decimal point somewhere where it's going to be greater than 1 but less than 10. Now let's count how many places, or how many powers of 10, that digit needs to move to get to where it is in the current number. Now I'm going backwards, so it means I'd be dividing by powers of 10, so clearly it's going to be a negative power. So the decimal point's here, so we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's to the power negative 13. Okay, so now what I'm going to do is write these two numbers in standard form. So looking at this is 79.23. So I need to move the decimal point so that it's greater than 1 but less than 10. So it's going to be 7.923. And then we've got to work out how many powers of 10 I need to multiply this by to give me this number. Well, hopefully you can see it's just multiplied by 10 to the just by 10, which is 10 to the power 1. We know that because I'd have to move it there to give me this number here. Now let's have a look at this one. Again, it's a small number, so the significant figures that we're dealing with are 1, 2, and 3. But I'm going to put the point in between the 1 and the 2. And we count, if the decimal point's there, how many places back do we go to get to the number? Well, it's 1, 2, 3. So it's multiplied by 10 to the negative 3, which writes in standard index form. Now, how is this useful? Well, we use this because if we need to do some large calculations, if we needed to do speed equals distance over time or something like that, and we have the distance of the Earth and we have the speed of light or something like that, we're dealing with very small numbers, or very large numbers. So it's good to have this like this. Now to type it into your calculators, you just type in, so if I wanted to type this number in, I would type in 7.923 times 10 and then use your power button 1. Okay, so that's how I would write that number in. All right, significant figures. Let's talk about pi. Pi is a very famous number. So pi, rounded correct here to 2 decimal places, so that means places after the decimal, is actually a number written with 3 significant figures. Remember, a significant figure is a digit. So this is 3 significant figures here. If I wanted to write, keep going, 3.14159. Pi is now written to 1, 2, 3, 4, 5, 6 significant figures. Okay, so the number of digits tells you the number of significant figures. Here, this number is actually written only to 3 significant figures because these zeros don't count as significant figures. This is a 4 significant figure number, and so on. And that's pretty much everything you need to know about standard form and significant figures.